confidence interval is an interval of plausible values of the population parameter. So values that are inside the confidence interval are plausible values of the population parameter, while values outside the interval are not plausible. They're values that were rejected when doing a hypothesis test. So let's look at an example and several questions to really break this down. So suppose we are 95% confident that mu is between 150 and 160. So I am giving us a confidence interval here for the population parameter mu, the population mean. And we're saying we're 95% confident that the population mean is some value between 150 and 160. So first it asks us to just go ahead and label this all on a number line. So if we have a number line, and we have here the number 150 would be on the left side, 160 is on the right side, we have 155 would be right in the middle. I'm saying that the confidence interval is the values from 150 up to 160, meaning we think the true value of the unknown population parameter falls somewhere between 150 and 160. We don't think it's higher than 160. We don't think it is lower than 150. It's just somewhere between 150 and 160. It then says to write this interval in interval notation. When you write a confidence interval in interval notation, you always write parentheses, the low value, comma, the high value, and then end your parenthesis. So our confidence interval, we think mu is somewhere between 150 and 160. So I write it in parentheses. The low end is 150, the high end is 160, separated by a comma. That's interval notation. Next, it asks us to identify the observed statistic from the sample that created this confidence interval. The observed sample statistic is always the value that's exactly in the middle of our confidence interval. So our confidence interval is 150 up to 160. The value right in the center of that would be 155. So our sample statistic is 155. Now, what would be the symbol for our sample statistic? It must be X bar. Because this confidence interval is an interval of plausible values for the population mean, mu, the sample statistic must have been a sample mean, X bar. So our sample statistic is X bar equals 155. It then asks us to identify the margin of error for this confidence interval. The margin of error, which we often write as MOE, is just the distance between the center and the outer values of your confidence interval. So on our labeled drawing up here, the center is X bar equals 155, and the distance from that center value up to the outer edge of the confidence interval, in this case, is 5, and that is the margin of error. Alternatively, you could go the other direction. The distance from the center to the lower end of the confidence interval is 5, which is the margin of error. So next it asks us to identify the confidence level. The confidence level is 95%. In the intro sentence here it said we're 95% confident that our population parameter is between 150 and 160. That 95% is called the confidence level. It's how confident we are that the true value of the unknown population parameter is within that interval. 95% confidence. Now, how does that relate to the significance level alpha? Well, the significance level alpha would be 5% or 0.05. To find the significance level, you can always take 100% minus the confidence level, or vice versa. The confidence level is 100% minus the significance level. When you add these two together, confidence level and significance level, you should get 100%. All right, and lastly, it asks us to kind of think about what is the relationship between a confidence interval and the hypothesis testing process? So the confidence interval is an interval of plausible values of the population parameter. It can be created by conducting a series of two-sided hypothesis tests on hypothesized values. So again, let me just redraw that confidence interval. We said that our confidence interval ranges from 150 up to 160. What we're saying here is that the values between 150 and 160 are plausible values of mu. They are values that if you did a hypothesis test on that, a two-sided hypothesis test on any value in this interval, your conclusion from your hypothesis test would be that this value is plausible. So for example, if the null hypothesis were that mu is equal to 157, and the alternative is that mu is not equal to 157, since 157 is in the confidence interval, you would conclude that the null is plausible because the confidence interval is an interval of plausible values for mu. So that must have been the case that the p-value that you got when doing this hypothesis test, the p-value is big. In this case, bigger than 0.05, bigger than that significance level. And that would be true if you did a hypothesis test for mu equals 157, if you did a hypothesis test for mu equals 151, if you did a hypothesis test for mu equals 154, any value in that yellow range of values, if you did the two-sided hypothesis test, your conclusion would be that the null hypothesis is plausible, that that value of mu is plausible. But the values out here above 160 and down here below 150 are not plausible. If you had done hypothesis tests, two-sided hypothesis tests on values in these ranges, your conclusion from your hypothesis test would be that the null hypothesis is rejected and that we support the alternative hypothesis. So for example, if we hypothesized that mu is equal to 162 and had an alternative hypothesis that mu is not 162, we would say that the null hypothesis is rejected, that we do not believe mu is equal to 162. If we had a hypothesis that mu is equal to 146, since that's below 150, we again would reject that hypothesis. Interval of plausible values. A confidence interval is an interval of plausible values. If you did repeated two-sided hypothesis tests on the values within this interval, you would get a conclusion that the null hypothesis is plausible. And if you did that same type of two-sided hypothesis test outside that interval, you would conclude that the null is rejected.